All right, now I want to talk about intrusion detection systems. And there are two key ones out there right now because they're open source, Snort and Suricata. Um, so what is an intrusion detection system, or an IDS? So this monitors network traffic and will generate alerts when traffic matches known attack signatures or behavioral baselines, but it doesn't block anything. And these are useful for constantly monitoring it, and you can have it trigger when there's a specific connection across a specific port, or you can have it trigger when a set threshold is exceeded. There's also IPS, or intrusion prevention system, where this typically will run on the firewall or somewhere on the network and traffic will pass through it. And this will actually actively block or drop the packets that match rules. So commonly you'll have a IDS, IPS system all running on the same host, or the firewall, for example, and it will be responsible for monitoring it, sending off an alert, and then sending that to the IPS, where it will then take action on that particular alert by either blocking it or restricting it or doing something. The downside to an IPS is if it's not configured correctly, you can easily block legitimate traffic. False positives will cause lots of problems. And the downside to an IDS is it's only monitoring and alerting. It's not actually taking any action. So another system or an administrator would actually need to take that alert and then decide what to do with that, or to ignore it, or something of that nature. There's network-based IDS, or NIDS, and there's also host-based IDSs, or HIDS. And so those just are defining where they run and what they can actually look at. Snort and Suricata are both network-based IDSs. Host-based ones is like OSSec or Wazoo, and you can combine all of these into one system and utilize multiple versions of everything. So kind of the difference between Snort and Suricata. Snort was developed by Cisco. Suricata is Open Information Security Foundation. And both of them are open source, but Snort is older, so it's only single-threaded. Suricata is newer, multi-threaded. Moderate traffic, Snort will work, but again, Suricata is better. It's just because multi-threading. The rule formats, they will have their own rule formats. There's a lot of overlap between the two, but it's just a matter of learning what they are. Protocol detection, Snort is all port-based. Suricata, you can do application layer protocol detection, so you can do more than just ports. It can also do file extraction, where Snort can't. There's scripting. It will also have Eve JSON. So when we talk about security, Eve is the eavesdropper. So there's Alice and Bob. They're the two people that talk to each other, or client and server. And then Eve is the one that looks at it. So Snort, you can, but it doesn't do it natively. Suricata natively creates a JSON output of everything, and JSON makes it a lot easier to programmatically analyze it and manipulate it. And both of them have community rules. Emerging threats is one of the big ones, and there's community rules, and there's also you can pay for a license and get the pro rules from them as well, which has more built-in detection, so you wouldn't have to code it yourself. So kind of looking at the rule, there's three sections. There's the action, the header, and the options. So the action in this particular one is alert. So it will just alert whenever it sees that. If it's running as an IPS, then you can drop it or you can reject it. You can also just pass and let it allow it. The protocol is going to be TCP in this case. You could put HTTP for web traffic. You could put DNS for looking at DNS traffic. So it just really kind of depends upon what you're looking for. And it does support quite a wide range of all of those. And then you have your source and destination. So this particular one, it's looking from a variable defined as external net. And this is defined in the Suricata YAML file. So it's under /etc/suricata/suricata.yaml. That's where it specifies the external net and HTTP servers and home net and that sort of stuff. And so, or home IP, I think is what it's listed as. But this is saying it's alerting on TCP traffic from the external network to any internal HTTP servers that are specified over port 80. And so that any matches all ports that it's coming from to a destination port of 80. So if you remember back when I was talking about the TCP ports, in this particular rule, this is an administrator who has a web server running on port 80, and the clients which are connecting to it from the internet or from an external network, their port will be some random high number port. So that's why there's that any there next to external net. So it's again, if you aren't familiar with network, you just have to realize that the client will have a random port there. So typically you'll do any, and then the server you're connecting to will have a actual port number. And then it's using the dash greater than for a unidirectional. So it's just looking for traffic coming in. If you want to do bidirectional, then you would just use the less than greater than. And then the last part is going to be the options for this. So if any traffic matches this, it's going to tag it with the message ET web possible SQL injection. And it's looking for the content in the payload in that particular packet to have a union select. That no case means it's going to be a case insensitive search for it. So that union select, because one of the things is if you don't have that there and an attacker doesn't capitalize union select, well, then it won't match this rule. That SID is going to be a unique rule ID. If you create your own rules, typically you start at a higher number. That rev is going to be a revision for update tracking. So if a change is made to this rule, you bump up that revision number. So some other example rules, if you want to detect all Metasploit reverse shell to any home network, it's home net, not home IP, then it's an alert TCP any, so that goes from any address, any port to any of your internal network addresses, port 4444. And then it just tags it with that message, Metasploit reverse shell, and a unique ID of 9000001. And this is revision 1 of that particular rule. Looking at the detect nmap SYN scan, so rapid SYNs, no ACKs, that typically is going to be a port scan or something else. So it's looking for traffic coming from anywhere, from any IP address, going to any internal address, any port, and nmap SYN port scan is how it's getting message. And it's looking specifically for flags where in the TCP header, there's a SYN flag and not an acknowledgement flag set. And then the threshold is type both, track by, source, count 30, seconds 5. So it's going to look at that and it's going to count every time it sees this. If it sees more than 30 of those packets in a 5-second window, it's going to trigger this flag. Looking at DNS queries for suspicious DGA-like domains. So again, it's alerting on DNS from anything to anything over any ports. And it's looking, it has that message there, but it looks for a DNS query where the content is dot, and then that PCRE is a regular expression. If you're unfamiliar with regular expression, well, look it up because it can get quite complicated quite quickly, but effectively that's looking for up to 40 characters from A to Z and 0 to 9. And it's looking for all those, and if it matches, then it triggers. detecting ICMP ping with oversized payload. Again, alert ICMP, any, to any, oversized ICMP. If the D size or the packet size is greater than 256 bytes, the data size, and the I type is 8, which is the echo request, then it will flag that. So that means that somebody is sending a larger packet and something is not quite right. So when you run this, well, first you need to install it. So you can do a sudo apt install suricata. You can run this against a pcat file that you have using the -r flag. And then you can also log it somewhere. It does install automatically. So after you install it, there's etc suricata, suricata.yaml. There are also some set rules in a rules folder inside of there. There's also another location on the homework will have you do this under /var/lib/suricata/rules. So the YAML file actually checks that other rules location and loads those rules as needed. So you can create your own rules and put them there. You can run this on a live interface, so you can pass in -i for ETH0 or whatever your interface is. You can get specific rule sets. So there's that -update, which will let you do the update and get the emerging threats rules. Again, it's not going to be the pro version. It's going to be the community, but that will have a lot of stuff on there. And then you can read the eve.json alerts by passing it. That's just a JSON file, so you can install JQ on your system, and that will let you look at the JSON there, or you can have a Python script or some other script that will analyze the JSON file and look at it that way. And then it will write out a couple of log files. So the fast.log is just going to be the alerts that were flagged in there. The eve.json is going to be that detailed JSON log. It can get quite big. And then stats.log will be various statistics for its particular run. So one of the things that you have to take into account is false positives. False positives is when legitimate traffic will trigger it. And there's lots of ways of getting false positives. And so you have to take care to make sure that you don't have too many false positives. Some false positives are usually not too bad, but you want to manage it to where the majority of what's flagged is legitimate stuff, and you don't have a ton of false positives, because that causes a lot of what's known as alert fatigue, where as you start seeing all those false positives and you start skipping past everything, and you might miss something which is legitimate. You can also add suppress blocks to silence known false positives. So like internal IP addresses or specific signal IDs, things of that nature. You can add in threshold rules. So we saw that slide or two ago, where you have a count over a time frame, and if it exceeds that count, then it flags it. You can also whitelist internal scanners. So one of the things that will trigger this is vulnerability scanners like Nessus, OpenVAS. There's a couple of other ones out there, but those purposely try to scan systems for known vulnerabilities and known exploits. Well, if you have a system looking for things which are scanning for known vulnerabilities and exploits, well, it will flag Nessus or any other system. So what generally happens, especially with penetration testing, is the penetration tester will come from a specific IP address, and so you will add into your IDS a whitelist for that IP address while that scan is going on. So if they're doing something which would normally trigger a log event, that doesn't actually trigger, and so you don't get those false positives. So deployment, you can have what's known as a span port or a mirror port. So on a network switch, a network administrator can add in or can specify a specific port which captures all traffic that goes across that particular switch. That's done at the network level, and it's not done at a device level, but it basically lets you plug an IDS into a port, configure that port to capture all traffic or have a copy of all the traffic being sent to it. No one else knows that on the network, and you get to see everything which goes across that particular switch. You can also get a network tap, which is a physical hardware device, which sits in between the two devices physically and just captures everything. It's a little bit older school, but it's very reliable, and it's also impossible to detect. There's an inline IPS mode, and there's also host-based. So there's several ways of doing it. I will say that kind of running it on a host and just having a copy of all that traffic being sent to that host, or having it run on a firewall is probably a lot more common, but there are various other ways of doing that. So again, key takeaways: IDS will alert on that suspicious traffic, IPSs block it. Suricata can function as both, but we're not going to worry about the IPS stuff. We're just going to do some of that IDS type analysis with it, but it can work on all of those. And there's those three parts of the rules. So there's the action, the header, and the options. The signature ID and the revision is for rule management and update tracking. False positive management, make sure that you minimize the false positives when at all possible, but don't get too aggressive because you don't want to miss legitimate alerts. And you can analyze it through that JSON file, which is logged. And that JSON file will be, you can ingest it into a SIEM, which is a security information event management. And you can analyze it there and run all sorts of statistics and data across that, or threat intelligence platforms.